Alright guys, welcome to our second chapter on rigid body distractions. So what we have now is that we can break the door like this, right? That's okay, but apparently it's not that attractive. A few things that I don't like. One of the things is that the pieces are too big and it just looks like, you know, kind of like a small thing instead of like a big door. So I'm gonna go ahead and change the size, and because this is all non-destructive, I can of course do that. So I'm gonna go for the scatter here, and instead of 160, maybe I can make that like I don't know, 300 for now, just to have like almost twice as much pieces as before. Again, the more pieces or the more scatter point you're trying to get, right? The simulation, the slower the simulation will be. So just be aware of that limitation. Okay, now because of that, so I'm gonna do actually some smaller like fracturing on the primary part that I'm gonna simulate, like this part, right, where my ball is gonna hit, or the hitting point here. If this, for this particular project, I want that part to be like this area to be specific, to crack more, and I don't really need the other areas to crack more anymore. I don't even need these guys to crack actually, but I'm not gonna disable the cracking there. I still want a lot of cracks, but I do want the ones here to crack more. Okay, so let me try something here. I need to know where the hit point is, so let me simulate it again. And as you can see, the hitting points will be right here. Okay, so let me just create something to represent where it is. I'm gonna go create a sphere. Alright, and let me turn on the template and give it a translate transform. Drop that there and press. Let me also make it smaller, right, so it's easier to see. Press enter and just drag it to where the hitting point is. Somewhere here, right? So that's where the ball hits that wall, and I want that area or the pieces close to this transform basically to shatter more. Okay, so how can I even do that? Well, that requires me to query like piece by piece and see their distance to this particular transform. So I actually need to iterate through the pieces. Alright, now to do so, before assemble, let me hold down shift and drag this up to move all the nodes above it to go up. And before the assemble, right, before I put them into pieces, I'm going to iterate through all the pieces and do some more shattering. Okay, so here, let me show the wireframe. So here, I'm going to say for each guy, let me connect that to the assemble. So anything inside of those orange color will belongs to this for each loop. Okay, so for each piece that I'm gonna work on, so the in the for each loop, I'm gonna say I'm use the attribute name, which is actually what I want. If you go ahead and change the setting here to single pass, and let's actually focus on there, and you drag through the numbers, you can see different pieces are being showed up. I'm not sure why I'm still seeing the door. I guess I'm getting a bug again somewhere. So let me yeah, I'm not, oh, I'm seeing this guy actually. So that's So let me turn on the visibility here. Sorry. So when I go through the single pass number here, it's basically looping throughout the different pieces. Okay. So for every piece, I'm gonna try to figure out the distance from that piece to the hitting point I just created earlier. Okay. So instead of this for each loop, I'm gonna say attribute wrangle. Okay. And this attribute wrangle needs to know where this guy is, right? This new transform, right? Where this guy is. So let me grab that to the second inputs, and here I can do some comparisons. The first thing I need to know is where this point is. Okay. Sorry, where this piece is, right? The location of the piece, or more or less the bounding box, I guess. The bounding box of that piece, the bounding box center actually. So I'm going to say vector piece location will be equals to the bounding box. So let me get the bounding box center. I'm gonna get the bounding box center of the input 1. Input 1 is 0. Okay. And let's put semicolon there, Control Enter to do that. Okay. So this guy will get the bounding box center of the pieces you imported in. Okay. Alright. And I also want to know where this is, where this the transform is, right? So I'm gonna say vector hit point will be equals to the second input where it is. Now if you look at the attribute here, oops, I'm getting an error because I don't have that finished. If you hold down the mouse button and see the point number, it has only one point, so I just need to know the point where it is. Okay. So I'm going to say this guy will be equals to points, lowercase p actually, points, right? I'm going to trace some point attributes. I'm going to trace the second one, which is the first one's point, right? I'm going to trace the attribute called p. I'm going to trace the first point in there, right? Control Enter to run it. So now it's going to give me the first point, which is basically the point, right? It has only one point. The position of that first point. All right. Then I'm going to go say I want to know the distance. So I'm going to say the distance will be equals to the piece location, right? This guy, and minus the hit point. Right, I subtract these guys, I'm getting the vector between those two, and I can know the length of it. So to get the length, just need to go ahead and type in length. I can say float length or distance. Actually, I can just do it right here. Instead of do all the things here, I can maybe just do float distance will be equals to length of these two. Okay, Control Enter to run it. Now this length, this distance now is basically the distance from every piece when we iterate through the loop. Every piece is distance to that hit point. Now I'm gonna use if to figure out what to do with it, if and else. Right? So if let's say if the distance that we're getting here is smaller than a channel, I'm gonna create called shatter distance, shatter range, right? If it's smaller than that, we shatter it. So let's give it a group. So I add group underscore shatter will be equals to what, meaning I want to shatter it. Okay. I guess I just need this. I don't need else because I just need to mark things that I want to shatter. Others will be default to 0. So Control Enter to run it and create that. And I can change the shatter range to define where or how do I want, or how many pieces I want to shatter based on this range. Just to make things easier to see, I'm also gonna visualize it by typing in the @cd dot just cd, maybe cd dot something dot blue equals 0. Okay, so I'm just deleting the blue color. Okay, let me crank up the range. You can see this guy becomes yellow. Let me actually change that to green so that we can see the difference. So the more I drag it, I should see more pieces becomes purple. The reason it becomes purple is because that the distance from there to the center is smaller than this value, meaning they're really close, and I want to shatter these guys. I just need to define like the pieces I really want to shatter, which are these guys. Now this is non-destructive, so now if I go ahead and change the transform, I should be able to update down the way. Okay, so let me drag it back and maybe make that make that shatter range just a bit bigger, so that maybe that's too big, 1.3 maybe. So okay, I like these guys to be shattered with more smaller pieces so that I can break it with a lot of more smaller detail there. Okay, so let me hold it down Shift and drag that up. Okay, and maybe drag that down so I can shatter it in the middle. So for every piece, I'm gonna do a shatter. I'm gonna do a Voronoi fracture again. Here, I'm gonna do the scatter thing. Scatter goes to there. Oops. Actually, I just want maybe a 5 or so. So it's calculated faster. Now everything is being shattered. And then I'm gonna say I will choose either to use these shattered pieces or not by using a switch. And put it here. The switch will read either the original shape here or the shattered results. Let me actually delete these two inputs, drag that first and that second. Alright. So what I'm trying to do here will be telling the switch when to switch to these shattered guys to use. Now how do I know it is shattered or not? Well, I already defined this group here, right? So I can retrace that information, but that information is on points, as you can see here on the points. It's not that visible, I guess. Maybe I'm not on there, but it should be there. Let's see, we have CDs. We don't have that attribute being created. Because that's we're looking through the pieces. This piece doesn't really have that. Okay. Anyway, if we go show everything here, let's change that to here. As you can see, we should be able to see the. Oh, yeah, we should be able to see it. Maybe. Here, as you can see, we have this point group called shatter, and we have that much point that does have this shatter. I don't want it to be there. I don't know why I cannot see them here either. Anyway, I don't really care. I also don't really want to see the color either, so let me delete that and change the run over on the detail so that every piece will just have that one attribute on the detail. Let's take a look. See, the group shatter is here, and I should be able to see some group shatter to be 1. So either 0 or 1 basically that I can get from this value. The shattered pieces will have 1. The unshattered pieces that I want to have will be 0, right? So I'm going to use that to choose either use shattered pieces or not. So here I'm going to say instead of using just a fixed number 0 or 1, 1 means reading the second inputs, which is going to be the shattered results, right? What I'm going to do here is going to say I'm going to read that detail information. I'm going to read this guy dot dot and /. I'm going to read the attribute rango3. I'm going to ask this guy about this attribute called group shatter. Okay, so group shatter and enter. Oops, got an error. So we're reading that guy. We're reading the group shatter. I guess this guy is more like at group shatter. Right, so now still getting the arrow, and the reason is I was typing that I was missing an argument. The argument will be like a 0. I mean that actually is a stupid argument. Like they just want to make sure that their argument amount is the same, so that 0 doesn't really do anything. It just has to be there. So let's press enter to do that. Anyway, now the reason being is because for other elements they do have a number. That's the number, but for detail you don't have a number, right? You see those are all having a number, so that they want that to be consistent on other callings to either your tracing detail point or primitive attributes. You want to have a third argument, but either way, as you can see, the result will be like you can see shatters being created here on those pieces that I do want to shatter, which are the pieces that are close to the hitting point, but the pieces that are far away will not be shattered. Okay, so that way I can have a lot of more detail here. Okay, all right. Now I can use this scatter to say maybe I want more, so let's say 8. As you can see, I have more things there, maybe 16. Because I'm shattering less pieces, I can go a little crazy or overboard on how many I want there. Okay. Now everything should still work. Let's go back to the top input. Maybe also turn off the wireframe and just simulate it. But you can see things are going a little crazy. It seems like it's trying to blow up everything. Okay, now there could be some reasons, but if you go to the door simulation here, one of the things you do see that is weird is that I somehow lost all the glues that I should have, and some of the glues are going crazy, right? That shouldn't be like this. Now there is a reason, as what I mentioned in previous class, that the glue is based on the name, right? The piece name. But when you shatter new stuff, this new stuff will not be given to new shatter names or new piece names. As you can see here, the piece name is gonna also be like 0, 1, 2, 3. So all those small pieces, instead of using the old piece name and add new piece names when you have more shatters, they'll basically be renamed from, again, 0, 1, 2, 3, depending on how many smaller shatter pieces that are being created. Apparently, I have repeated names for piece 1, 2, 3, and things like that. So I can do some fixing to the name before I assemble that. Or actually, I can go to the assemble and check on create names. That should allow me to recreate the names for every piece. That's just one of the convenient ways, I guess. That should fix the problem and make the simulation go normal again. Let's take a look at the door simulation. As you can see, the glues are going back, are back now, right? So let's go play the simulation again. As you can see, it's now working quite nicely, and pieces are being blown away like that. Okay. Oops. Yeah. So I think my ball is going like too crazy. It's blowing all the pieces away like that. So let me go back to the simulation. I'm gonna tweak some of the parameters. Anything you change could result in the could be changing the simulation result a lot, so you may want to go back and do some more fine-tuning. Like maybe my ball here, let me actually rename this guy, like this is the door and that is the ball, so that we're not missing those two up. So let me grab the door here, actually the ball here. I'm gonna say please don't move so fast, maybe 30 here, and let's play the animation. Alright, that feels a bit better. Maybe even that's too much, maybe 20 or 15, just then, you know, gradually make that smaller and smaller until I am happy with that's too small. Okay, so I'm gonna go back to 30 and maybe lower down the physical properties. The density is, whoa, that is like 8 zeros, I guess. So I'm gonna say 6 zeros and see if that works better. Alright, now it's not so dramatic, I guess. Maybe even just a thousandth as the default setting. Let's see what happens here. That's too weak, so maybe one more zero here. So it's like 10 times weighter, heavier than the others. It's getting there, right? Let me go back and give it one more zero. Let's hit it. All right. Let me make that maybe half. At some point, I will be able to find a proper value here, so it's not going too crazy, but it's still gonna be able to poke through like that. Alright, I think I like the result I'm getting here. Okay. So let's talk about how we can vary glues. Because right now everything is glued together using this green glue, this guy here. But you can actually create all multiple different kind of glues, so that some of the glues are stronger, some of the glues are weaker, right? So how can I even do that? Well, as you could remember that the glue is basically based on the piece name on the points. Every primitive or every line have 2 points, right? Every point have a piece name which represent the piece that they are gluing between, and that line also have a constraint name, and the glue setting here will be using that name. So if the name on this line here, the constraint name, is the same here to this glue, that means this glue is basically controlling the strength of that line. So let's say if you have a different line here that has a different glue name, and you have a different glue here too, and that has the same different glue name, then that new glue is controlling that line. Okay, so I'm gonna go and create or make variations on these lines, right? So let me go back to the door here. I'm gonna say I'm gonna random or create bigger patches and make the patches hold together, but make the glue between the bigger patches to be weaker. Okay, so before this attribute wrangle, I'm gonna say I want to use a attribute lap. Okay, and drag it in here. This attribute VOP will be used to actually create some color here. And let me actually do that, and you will see why I do colors. But anyway, I'm gonna drag out from the P. I'm gonna create a Voronoi, Voronoi noise. Okay, we used that fracture before, this kind of way to do fracture. Now I'm gonna use it to do noise. Okay, now it's gonna give me a bunch of outputs. I'm gonna use the seed, and I'm gonna then type in random. Okay, the random will give me a random color or vector. There should be the same thing, but let me use color and connect that result to color. And you can see the colors are now being all, you know, colorful, right? And you can see some patches or some parts are having the same color, but some lines are having different colors. One point is having this blue color, another point is having this orange-ish color. So what I want to do is I want to make any line that is having the same color on its two ends, or the 2 points on that line. If those 2 points are using the same color, I'm gonna make that glue stronger. So that will hold these pieces all together, right? But if, let's say this line here, its 2 points are having different color, then I want it to be weaker so that the glue is weaker here and they can easily break. If I do so, then those will break first, and the glues in the middle maybe will break if you hit it hard enough, or maybe it will break when it falls down on the ground, right? Whatever that could happen, but I can actually make variation now just based on the color information on the 2 points of any of the lines. Alright, so let me go back and actually do that. So here, what I was trying to create is just one glue. I'm not going to do that anymore. I'm going to say I need to know the points on any of the lines. So let's say I'm going to create a int point number, one number, the point number of the first point of any line. It's going to be equals to vertex, right? Vertex. And I'm going to look for vertex points in this function. Okay, I'm going to say, okay, this vertex point, I'm going to look for a vertex point on this primitive. I'm going to look for the first vertex point of this primitive. So I'm going to read a primitive. Actually, yeah, I'm going to read the first. I'm going to read the primitive vertex. Okay, and I'm going to read again the first one. The first one is the first inputs, right? And I'm gonna need to know the primitive number. Sorry, I'm a little tired today. Primitive number, the number of that primitive, and that's gonna be at prim number. Okay, I'm gonna read the first vertex. Okay. So what this means is that I'm gonna get this first vertex, and I'm gonna get the point, the first inputs, and that vertex, the first vertex. Sorry, this 0 means the first inputs, which is what's connected here, right? I'm gonna read that guy's first vertex, and I'm gonna look for that vertex, the corresponding point number of that vertex. Okay, I'm gonna do the same thing for the second point. So point 2 number will be equals to vertex point. I'm going to say also the first inputs, also the primitive vertex but I'm gonna look for also the first inputs and prim number, and I'm gonna read the second one and control enter. So basically this gives me the point number of the first point and the point number of the second points that are connected to that primitive. Okay. So now I'm happy with this. I just need to know the number, the color of that point. So I'm gonna say vector, because color is a vector, right? So I'm gonna say point 1 color, or CD, will be equals to points. Point can retrieve any attribute of any point. So I'm gonna say I need the first input again, and the point number I'm looking for is the point 1's number, and I'm gonna read, actually that's gonna be the last thing. The second thing I'm gonna read is CD as color. So first inputs, CD attribute, and point number is that guy. Control enter to run it, right? We cannot see anything yet, but let me copy this code. Control C, Control V again to copy a new line, and it's gonna be point 2 color will be equals to points and point 2 number. Oops, 2 number. Okay. So I'm basically getting the color now. Then I can really say if these two colors are the same. Means those ones in the middle, right? Those solid lines without color changing. I'm gonna make their glue really strong, so as at constraints name will be equals to glue strong, and if not, then I'm gonna say else will be as at constraint name will be equals to maybe not strong, so glue weak, and run. As you can see now, if you go through the glue names, you see strong ones and weak ones. So now I'm basically varying the glue name now. I have two constraint name, or basically constraint name has two different values on different lines. The solid lines are having glue strong as their constraint name value, and those ones that does have color changing, they're having glue weak as their constraint name. And I can now go back to my simulation and really say, okay, here I want two glues now, so I'm gonna create a merge and grab that to the input. I'm gonna merge in another glue constraint relationship, and I'm gonna say this guy will use a glue weak. As you can see, the color just changes to red here now, and the other guy will be glue strong. Okay, I must have tapped that wrong, so let me go back and take a look at my naming. So glue strong, right? Go back. Go back here and go to door simulation. Then change that guy to glue strong. Okay, now you can see I have some green connections. Let me make that more visible. Back, go to glue guide. I'm going to change that to maybe a visible blue color. Okay, and I have the red colors. The glue guys are stronger guys. Those guys are holding together much stronger than the red guys, and you can see more glue red and less red because the glue are the primary ones. Those guys are pretty even because they're just loose, but I don't really care because this part doesn't really fall, at least not that much. I shouldn't make them fall because I'm just breaking this part. Anyway, so I'm now gonna change the settings of the glue weak to make it really weak, like 0. 0 doesn't mean they will fall right away, it's just really weak. Any smaller movement can really break them. Okay, so let me go back to the flash shaded mode so I can do the simulation again. Okay. Alright, so I'm thinking like some of the glues are still kind of like really strong, and I don't have that much of a weaker glue there, so they're just not following or falling like really having enough weak glues to break down on the top. I want the top to actually fall down when I hit it. So what I'm going to do here is go back to the geometry. I'm going to say I want smaller chunks and more blended edges. So that means just more frequency here. Let me change that. As you can see, I'm having more and more like varied edges. Okay, so with that being set it up, I should be able to see like it should be able to show me more red lines. Red lines are weaker lines, right? So let's take a look at it now. As you can see, when I hit it, more things are falling down because there are just more weaker parts. Okay. I like actually the falling down part here on the top. Looks pretty cool actually. As you can see, these guys are breaking down, but not necessarily like everyone is falling to the same, or everyone is like falling on their own. As you can see, some of the pieces like this guy and this guy and that guy, they're falling together because they're having strong hold between them. Hopefully I can find some here too on those deep rays. Like here, this piece here, right? It's holding itself together. I can actually show you if you can see the line here, the glue constraint line here, that means they're still holding together. So I have a bunch of pieces holding together by the line, and that's one of the cool things. And you don't see much of the red line because they're already broken. Okay, so basically what this means is that I have some of the pieces are still gluing together even I hit it, but other pieces are not. So that way I'm able to basically make have variations, not just on the size but also on the shape. Okay, but I don't quite like this result. I think it's like shattering like really fast, and all the pieces are being break down like too much. So I'm gonna go back to the attribute valve again, right? Maybe let me actually promote this guy so I can change it on the outside. Maybe I don't want that much of a frequency now, so let me bring it up, bring it down just a little bit so that I can have more pieces hold together. Let's go back to the door simulation again. Let's say the glue strong here. I'm also going to make it even stronger by giving it one more 0. Okay, so that those guys, those blue guys, are really strong now. Let's do one more simulation. Alright, now as you can see, when I hit it, some pieces are still trying to hold together, as you can see the blue line, right? But they're also breaking and falling down because the connections or the glue between these bigger chunks are weaker glues, so that those will break. Okay, so now you can see the breaking process becomes a bit more dynamic, and my pieces are also more dynamic. I have bigger pieces and smaller pieces, right? So that way, this kind of like breaking, it just feels more organic. Okay, and that should be what's happening in real life too, because different pieces may have like the material we use, right? We create are not like pure or even, right? So it's a mixture of different kind of like stronger holds or weaker holds, and by using that, all those things we did earlier to vary the gluing can really help to mimic that nature. So now if I play this again, as you can see, the shattering just feels much more organic. It's almost like having this timing happening to like something breaks first and gradually breaks a little bit more. So this is just much better than before. Okay. Alright, even that guy is trying to eventually fall down. Okay, so if I give it more time, I believe that part will fall down. Maybe. Or yeah, it's trying to keep going. Yeah, it's still keep going. I think it will eventually fall down. Okay. As you can see, the first hit breaks almost all the red lines. So let's say maybe I wanted to hold it together just a little bit more stronger instead of 0. Let me try 10 and let's see what's happening. As you can see, some of the red line disappears, they broke, and then some of the red lines are still holding together, like these guys. And when they hit something, like when that thing hits the ground, I believe it will basically fall again, right? You see now the red line disappears there because the push there also becomes really strong when it hits, and so it falls down too, and the other parts start to falling down. Okay, so by tweaking the parameters of the two different glue, now you can really make some really interesting shattering. Again, this will, or already I believe you can already feel that like the power, right? The power of the different glues that you can create to really make things look more natural. Oh, by the way, turn on the real time if you want to see how actually everything looks like. Okay. So I really like how the big pieces start breaking and breaking down again when it hits the ground, so I'm gonna keep that. For these guys on the other side, I'm thinking maybe maybe I can also make them fall down. Maybe I can make these guys weaker, right? So but I'm gonna leave that for you to do if you wanted to try, but I think you already know the concept, and you can do a lot of like fine-tuning on how you create glues. You can create even more glues, and you can even make the glue change down the way, right? Make them weaker based on whatever, right? So okay, I'll leave that for you to figure out. So this is basically some more controls that you can do with Shatter. Alright, so that's gonna be what I want to go over in this tutorial. Alright, thanks for watching, see you next time.